When working with functions, it's very important to know the domain. Sometimes it will be stated, such as f of x equals x plus 5, when 0 is less than or equal to x, which is less than or equal to 8. If it's not stated, then it's the set of all real numbers for which the expression is defined as a real number. For example, if we have f of x equals 1 over x minus 3, there is no domain stated, so it's whenever x is defined as a real number. So the only time it's not defined as a real number is when the denominator equals 0. So to find what value that happens at, we take the denominator and set it equal to 0, solve for x. So add the 3, x equals 3. Now what happens when x does equal 3? Let's plug it in. Let's see, f of 3 equals 1 over 3 minus 3. That goes to 1 over 0. We're divided by 0. We can't have that. So x cannot equal 3. These are restricted values. It makes the function undefined. So if we use set builder notation, we could write this, its domain is x, where x is not 3. So if we were to find the domain of f of x equals 1 over x squared minus 4x, we'd take the domain, set it equal to 0, x squared minus 4x equals 0. We see there's a GCF of x, so we take it out, x times x minus 4 equals 0. So now we separate and set them both equal to 0. So we get x equals 0 and 4, but actually those would make them undefined, so they do not equal 0 or 4. So set builder notation. X, where x does not equal 0, x does not equal 4. We can actually write that using interval notation if you would like. We can go from negative infinity to 0, union 0 to 4, union 4 to infinity. For f of x equals the square root of x squared minus 16, we know that we cannot take the square root of a negative number. So we need to have whatever's inside the root greater than or equal to 0. So now it's an inequality. So we solve for x. X squared is greater than or equal to 16. So now we square root both sides. And x is, it becomes a compound inequality, where it's going to be less than or equal to 4, and greater than or equal to negative 4. So if you were to write this using set builder notation, we'd have x where negative 4 is less than or equal to x, which is less than or equal to 4. Or if we use Interval notation is from -4 to 4. So if there's a root in the denominator, we know we can't take a square root of a negative number, and we can't divide by 0. So instead of setting it equal to greater than or equal to 0, it's just greater than. So we take that x plus 2, and it's greater than 0. So we get x is greater than -2. So the domain would be x, where x is greater than -2, or if you use interval notation, from -2 to infinity. If we use some word problems, the surface area S of a sphere is a function of its radius, r, given by S of r equals 4 pi r squared. Now we're going to find S of 2 and S of 3. So if we find S of 2, we replace r with 2. Get 4 pi 2 squared. We get 2 squared is 4. And 4 times 4 is 16, so it goes to 16 pi. And let's leave it exact by using pi. So S of 2 is 16 pi. If we were to do S of 3, 4 pi times 3 squared. 3 squared is 9. And 9 times 4, 36 pi. What do our answers represent? Our answers represent the surface area of the sphere. With radius 2 and 3 respectively.